process, can we, remove it or increase the vertical height?
Never been asked that question. You can't remove it by itself because it really should be heated, and you'd have a big vacuum leak because the heater's part of the seal to the atmosphere on the bottom. Go ahead and close that. And then over here hit PC pump.
Do you have something that is discussion about this? You have something smaller piece about this pipe, which you can put in.
Yeah, so
You have something. No.
just come
You
out
have something already. Started.
he's going to put in a PC pump, and then once the recipe is complete,
Okay. So, something that needs to be taken in consideration with your sample that you put on is the equilibration time for it to come to temperature. In this case, how long is it going to take the wafer to come up to the temperature set point is 332 degrees. 332 degrees means 300 degrees on that sample.
okay.
By the time I'm done explaining the recipe, we're all going to be there.
Okay.
Wafers, pieces of wafers, not a problem. As you start to get into thicker things and things with greater mass,
Like what they just showed you?
yeah, that's going to come into, some sort of factor.
Then it takes like an hour or something for stainless steel.
I wouldn't say it would take that long, but I would say at least 10 minutes. So we have the sample set in there. We're going to close this. I'm going to skip through the screens with the exception of here. So you're going to, so here we're going to be doing the TMA H2O. It happens so fast, you may or may not see these open and close. This is definitely something you can't do manually. It's just not fast enough or consistent. So this is something that it's a process you have to let the recipe do it. So this is where you're going to see anything coming on. You'll hear the solenoids more, then you'll see this. In the process phase, this would be the AB. The reactant will come up, TMA, then it'll get a dose and a purge, then reactant B will come up water, and it'll give a dose and purge. This is where you'll see what the pressure is, the temperature. We opened it up, so it's still coming up. That one kicked off. This kicked off with the safety thing, so it'll be up to temp by the time I'm letting you know. So this would be the temp, this would be 332. And then your cycles, we'll do like 400 cycles so we can see something. And it'll be in good condition. And you'll see a population here. The heating stream will cover tomorrow, and the vacuum stream will cover tomorrow. So, and all of the other software stuff and the buttons will cover more tomorrow. So this is, you have two recipes. This is the one recipe. So it's BR process ALD aluminum oxide TMA-H2O. Were all you guys in the same training as on this system?
Most of them. Most of us.
Okay. So the recipe structure is similar. It's using the same software. So we have a big process recipe and we have sub-recipes incorporated into it. So on the first part here, it just sets, normally the scan interval between lines is about 1 second. So we're going to change that a little bit down here to 20. This is just doing a little bit of cleanup on the process. So the first sub-recipe is an ALD process active check. On here, this ALD process, this is set in a recipe. So this just checks it to make sure there isn't another recipe running. Also, when the recipe finishes, it unchecks that. That's where you could run into a problem if somebody just stopped or ordered the recipe as it was. The board should still clear it out anyway. But this just makes sure I'm not already running a recipe on top of it. Make sure that is not running. I went into a sub-recipe for the master recipe. So if you see this return to previous recipe, that means you could go back to the master recipe. So the next step is set abort process. This, in some steps of the recipe, in either one, this is like, what do I want the system to do if something doesn't go right? So this says, everything below this line, if it aborts, then do whatever this recipe says. And it's just an abort sequence. Then you run a sub-recipe, SR-ALD-IGF. That's the same process gas recipe we were running when we were conditioning. Brings you up to about 611 millisieverts. Then you run another sub-recipe, PSALD, AL2H3, TMA-H2O. On any of these, notice I don't have return to previous recipe. I'm going to click the sub-recipe, now I have it. So this sub-recipe, this comes down here. It's at the process phase. This process phase right here is this line, this process phase line. So what you see here is not generated from somewhere else. It's the recipe said put this here, so you know where it's at. Sometimes these words, especially completed, are used as an interlock. So it'll be a check to make sure something has the word completed. Another thing that could get you caught up if somebody stops it manually, then maybe the finishing recipe didn't insert the completed. Then you try to run a recipe that has a check step to make sure it was completed. Now it won't run. So you got to reset that manually to get back to a known state.
Do you have some preset recipes for some standard materials? Do you have?
Lots.
Okay. So how do we get those? Just email you? Okay.
So if you're going to be running hafnium oxide or zirconium oxide in the future,
Yeah.
then just say, hey, we're going to be running this. Do you have something already? We'll just log on to TeamViewer and we'll load it up. Then you take the hafnium or zirconium oxide, you load it on this phase 3B.
Yeah.
You do the same pump purge recipe loading. You do the same conditioning recipe as we did at atmosphere, the ambient temperature. But then you'll have to do it one more time at the higher temperature. So in the case of zirconium, you have to do the conditioning another 50 cycles at 75 degrees C. Because you're not, the vapor pressure isn't going to do anything. The first one will get rid of that, the packing gas, but you're not moving any material. You have to heat it up and then do a second conditioning. That's only for ampules that require heat. Not everything requires heat. So whatever you're going to run, there's a good chance that we already have a recipe for it.
Okay.
If we don't have a recipe, maybe it's something new you've seen in a technical paper or a white paper or something like that. Then Bruce, which is our research scientist up at Penn State, the guy just lives on AOD. All he's done for a large part of his life. He can give you a good benchmark starting point. And then you can get some information. Go ahead, run this film for 100 cycles. Go ahead and measure, give me the information. He'll work with people to get the recipe tuned into where it needs to be. Right. We work with, I can't say everybody, but almost everybody. The people we don't work with it like that is Intel. But I can't really say we do anything with Intel because we're not allowed to say that. But if we were to have some equipment at Intel, we wouldn't be working with them because they already know what they want to do. So that's a long answer to your question. Just context.
That's good.
This isn't. Service will take care of the PVD. AOD will be either myself, Noel, or Bruce. And we work with all our customers really, really closely. So if there's a question on anything, just ask. We're more than happy. Plus, I have to come to ARL. I have to come to Air Liquide. I have to go pass this way a few times a year. So I could stop by. Not a problem. So this part of it's going to set up your time and your reactant steps. This sets up the matrix. The PMA dose, 10 first, 10 second H2O. So everything in this recipe is what populates here. This line and these lines.
So right now we only have 2 sources. But your software have multiple ones.
Oh, we can just dump it in. No, this is a standard configuration. This is standard base configuration for yeah, we can log in, put it on. So that's that sub recipe. Then this just sets the process phase. This, anything that is a user set value, same with this one, will pop up on a screen. And any user set values in this recipe, when you hit run recipe, you get another screen that pops up. So those are, you can change those for that recipe. That doesn't change the default value, it just changes it for that run. If you don't want it changeable, then you can change this from a user set value to a set value. And people can't change it. So this time right here, the 600 seconds, this is just the equilibration time for it to come up to be temperature. Whenever you're changing different materials like you showed me, you're going to have to take into consideration the mass of that and how long it's going to take to equilibrate, roughly. Then this sets the counter back to 0 and sets the scan interval. This sets another statement, and then it turns on the active signal. And then the run recipe, this is the firing order. Yeah. So it's going to turn it on, turn it off, and then turn on out valve. The source one, the water valve. On and off. So one sub recipe sets the matrix up. This recipe tells it when to fire. Whenever I have the conditioning recipe, it's basically just changing this. And that's all you have to change in the recipe. So if you're conditioning source 1A, you change it to source 1A. Then whenever you're conditioning source 3A, you just change it to source 3A. I should have that. I hope I have that. Then that runs, and this is just go-to, so it's a looping. Go-tos you could loop back or you could loop forward. In this case, it loops back. And it checks it. Are you at the set cycle?
Oh, cut it?
just for a test piece.
We'll try it tomorrow.
Sure.
I don't know if it worked or not. We'll give it a shot.
I cleaned out with isopropyl just in case there was anything in there. So it
Okay.
should be clean, and if it doesn't work, it doesn't work. So.
Yep.
Nice wire.
Okay, so, and then it gets to the point where it ends the recipe, and that's it. So I might do a little bit of tweaking in this recipe depending on how it's running. But we're gonna just let it run through the rest of the day.
Okay.
So who wants to run it?
Dr. P?
Not me.
Too slow.
Well, let's go through the process. That's where we're gonna see it. Then you go to run recipe.
No, hold it for a second.
I'll
This
explain
is a
what's
break.
in run recipe and what's not in run recipe. Let me do a check on something here. Okay.
On, right?
Yeah, everything's on. So, yep. 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 So this is anything that had a user set value. Let's change this to 400.
Which one? This one?
Yeah, you change that to 400 cycles. You won't be able to visibly see 200 cycles.
Anything else?
This is the equilibration time here. So this is, if I wasn't talking, explaining the recipe, that's where you would be. Right now it's already been 10 minutes of me talking, so you can put that at 0.
Everything is second.
And then continue to look. It's either seconds or milliseconds. It could be either. Those are seconds. These are milliseconds. So everything is not the same unit. Then if you're happy with this, you continue to look.
All are subject to change.
You can change it just for this run. It won't change the default value. Plus you can change it on the fly too. Yep. You go ahead and close that. Just, yeah. So this is where it's setting up the recipe. Now it's populating here. The board. Ah, excellent. So we had an interlock and we had an abort. So it aborted. Why did it abort? Okay, come in here, process sequence aborted step 8 with the message. Step 8, you can click on that. Go ahead, click on the abort recipe.
Yeah, pretty clear.
So it's the child recipe, sub-recipe. Well, here, click on the interlock, yeah.
The read
Yep,
one, right?
yep, double click on that.
Double click.
Yeah, double click here. That's coming.
Okay, so it comes in, that's fine, it's brought it up to this.
Disable the
So this is the abort recipe, this is the abort ALD process recipe. So come to the ALD process recipe, the abort part of it versus
abort. There's nothing here.
yeah.
The ALD process support specific.
I'll fix that tomorrow.
Oh, okay.
I know the reason. It's hidden.
Oh, okay.
So, what happened, the safety circuit wasn't enabled. Okay, you could click on here too. On the interlock itself, this is the recipe.
Warning.
I'll get it so you can see this recipe. This says circuit safe, circuit not enabled. That was enough for me to know what happened. So, go to the vacuum, this circuit, the safety is not enabled. So why wasn't it enabled? And you're going to see this again a number of times. Whenever we vented, we lost the vac switch. We lost the vac switch, the safety valves kicked back. When we pump down, the pump recipe doesn't automatically reset that. So,
Please, sir.
because the vacuum requirement's made, you're going to see that, especially if you run this only once a week or once or twice a month. So now, okay, we're good to go then.
Round that thing again.
Yep. And if you want to clear out this noise, you can hit acknowledge.
Position,
You can do,
acknowledge.
yeah, you can acknowledge.
What I should do is
Round again.
Yep, you can do it again. Same thing you did before.
Thank you.
All right.
Yep. You can go back to process.
What is going on?
This is it, it's running.
It's running, right?
Now the resolution, we can tighten this up so you can hit the gear
Setting.
there. Yep. Go down to 1 minute right now.
This one.
Yep.
Same. What are these?
No, you can just hit the gear again. Now you can save that data. If you hit save that data, it'll push it down to a file. And then I'll go into the charts and stuff like that a little bit tomorrow. That's not in the manual, but I'll explain the charts. And then you can play around with that if you want. Because you can see heat curves. You can see, especially if you're running like, you want to see how your heater's performing on your ampule heater. You can watch the ramp, you can watch the curve coming up on this. You can set the values. You can do a lot of things.
Is that why you have a thermocouple attached to this line here?
Yeah.
This was just demonstration for a PowerPoint. But if you were doing hafnium or zirconium, you would put the thermocouples on just like that, and then you would use
Thermocouple monitor. Okay.
then you would use an ampule heater like this to heat the ampule. These thermocouples on here, we don't like where they're positioned because your chemistry's down here. Usually you have 50 milliliters of ampule, 50 cc ampule, and you're only having the bottom half. We want to know what the temperature of the material is. So we use this for heating, but we tape our thermocouples on so we know exactly where they're at.
Okay.
These thermocouples we just tie up for reference, and the one up by the valve up here is just for a spare. We use these. One will be controlled, one will be overcut. We want them down where the material is at. These are great for heaters, but we want to know where the material is. Because what was happening, we would put, different people would put chemistries on their system, and they would put different heaters, and the thermocouples would be in different points. So we wouldn't know if this was actually, if this was zirconium, if this was actually 75 degrees. Or maybe it's 78 degrees. Or maybe it's 70 degrees. So that was causing it was adding variation to your growth per cycle. We weren't confident exactly where it's at. So we just made the decision, we're going to put them where we know the temperature's at, and we'll just use these as heaters until eventually we can get the manufacturer to make them the way we want them. So you put this right
about halfway to about a quarter.
About a quarter to a third. Because they fill, whenever this is filled, this is 50 ml, they usually fill at about 25 grams.
Okay.
We want to know what the temperature of the material is. Because if we know what the temperature is, we know what the vapor pressure is. You know, if there's an 8-degree variance between what the temperature is because the heaters, that's a large difference on vapor pressure. So how can we be consistent on growth per cycle? We've been fighting this for years. Trying to work with different manufacturers, and they've come a long way. These fit better on the ampoules than they did before, but they still don't have the thermocouples where we want them. So we put the thermocouples physically where we know.
And how you plug it in to heat it up?
Oh, so this is source 1. You won't have that. Come over here.
Is this already a 12 cycle?
Oh yeah. So one is the TMA. This next one will probably be water. That was the water. So the water peak, that's the water peak. So I just changed from 9.5 to 7. These high peaks are the water.
It's higher, right?
Yeah. These are the TMA.
Okay. So you want to make it about the same height?
No. I want to get it closer to 30 millitorrs where I want it to go. Then I'll just change the recipe.
Were you adjusting the valve? Opening?
No, I'm putting my hand on the solenoid so I know which peak I'm looking at.
Oh, okay.
So, come over here. So here's where you plug the heaters in. And then somewhere around here, there'll be some extra thermocouples you can plug into. You should have put them in here. But that's where you plug the thermocouples into. But yeah, this, just come in around here. You'll have the thermocouple sticking out here. And then you wrap this up in here, and the thermocouples will drop down. Plug the heater in here.
So if you don't plug this thermocouple inside, how does the system know the temperature? So you have to plug it in, so it will kind of feedback.
Well, this is just power. The two sticky ones on the bottom, you'll plug into like thermocouples like this.
Okay.
I don't know where they're at right now, but they're here somewhere. Or you go back to the channel. The channels are over here.
So you specify a power level?
Yeah, it runs just like the other heaters. Then you can control the set point where the temperature is.
So that thermocouple plug into this one? Or thermocouple controller?
This is the valve. So it'll be down here. It'll be one of these channels. I can show you how to check that out tomorrow. Essentially, you just plug it in
Okay.
and see which one reads. The water peaks around 655 millitorr. So that's 40-ish millitorr. I want it around 30.
What does negative indicate?
Sorry.
What does negative value indicate? Minus.
That's just the increment. It's not a minus, it's just an increment. So this is set to 400 cycles. This is your step. These are your cycles. So you'll have come down here. Right here, you'll have the TMA 645. That's 30. That's what's really nice. So this width is actually your dose time, and this is your purge time. So you have 10 seconds. Now, whenever you start to lose material, you're running out of material, you'll start to drop out of that peak. That peak will no longer be there because you have no material to change the pressure. So this will run for 400 cycles.
So the time duration, right, from here?
Well,
No, it's not.
well this is the
time.
Sir, do you have any educational video on the operation of this one on the Esper website? On the operation of ALD? Or in YouTube?
Videos,
somewhere?
probably not.
Oh,
I don't think so. Maybe, but I don't think so. I'd have to ask Noah Bruce.
what is the coupon policy? Not to upload a video for operation of people.
No, we have certain videos for procedures and some small operations. It's probably just we haven't got to it yet. Yeah. You know, it isn't a policy not to have it. It wasn't a conscious decision by somebody saying, no, we're not going to do that. It'd probably be a good idea to do videos and just, if nothing else, for marketing.
Yeah, I mean it's very useful to have it.
Something like this, you know, there's no value in us, you know, porting the aluminum oxide record because everybody has one. This is not new.
I understand.
You know, if we were doing unobtainium or something like that, they'd be different. No, this is not.
So this computer is not connected to the internet.
It actually is. We connected it earlier for TeamViewer.
What we can do is we can open like a Teams or WebEx. We can record where you operating, right?
Yeah, you could do that, sure.
Right?
Yeah, that's different.
Easier to kind of see what's going on the screen.
Yeah, I haven't done that personally, but there's, you know, different software that can definitely do that. Absolutely.
Does it have Teams on this?
Probably not. We can check tomorrow, or we can check now. But this is just a simple AV process. Sometimes with water, you get a little droop at the end here. That's not abnormal. But this is how the aluminum oxide perfectly looks. deposition screen, same graph. A little bit different view. So tomorrow, we should be able to at least see some discoloration. You'll see a change on the heater. So you'll know something was put there. Then tomorrow we'll run through everything with the software, everything with the components. I'll do the hardware, then I'll do the software, then we'll run into the recipe, run the recipe, unload the recipe, and whenever everybody's comfortable with doing that, then we'll go ahead and change the water amp, put the other water amp to on, and we'll still have plenty of time for questions on either one. Oh yeah, you can click on anything you want.
Alright. We're good?